Welcome to Spring LIB.
Welcome to problem number 10.48, chapter 10 Dynamics of Rotational Motion. We are given that there is a rod, one end is fixed, that means this is the axis of rotation, and this rod can move with some angular velocity. Initially, the bug is at the position of the axis, so it doesn't contribute to the moment of inertia because I is equals to moment of inertia is equals to mr square, the usual formula. So the moment of inertia of this bug is zero. That means the bug remains at rest initially. So the rod is moving with angular velocity omega 1, which is zero point 0.4 radian per second. The length is zero point 0.5 meter. And we are given that initially, when the bug is at rest, the moment of inertia of the system is 3 into 10 to the minus 3 kg meter square. And then the bug starts moving towards the right, and finally it reaches towards this end. So final situation is this one. The bug remains there. And find that the velocity of this bug is equals to v2, which is the tangential velocity 0.16 meter per second. Now we need to find out the mass of the rod as well as the mass of the bug. So first we will find out the mass of the rod. So find out the mass of the rod. So let's say this is capital M and the mass of the bug is small m. So we will find out the capital M here. All right. We are given the two formula here, V equals to omega r and L equals to I omega, and conservation of angular momentum. Since there is no torque on the system, so the angular momentum is conserved for every time. No torque on system, therefore conservation of angular momentum. Conservation of angular momentum. That means whatever L1 is, L2 is. But we don't need to use for this part. We just need to find out the mass of the rod, and which we can find out using this quantity. So the axis of rotation is this one. So the moment of inertia of the rod is equals to 1 over 3 capital M L square. Since the axis of rotation is the fixed at the end of the rod, so the rod can move this way. So the moment of inertia is 1 over 3 ml square. So we know the value of the L, we know the moment of inertia, which is this quantity 1 over 3 mass L is zero point 0.5 square. Again, to point out that moment of inertia of the bug initially is 0. Since the bug is sitting at the axis of rotation, the bug initially equals to 0. The moment of inertia is 0. So it doesn't make any contribution to the I1. So therefore we have M equals to 0.036 kg. So that's your answer for part A. Very easy. Just equating this quantity equals to 1 by 3 ml square. All right. Now we go to the part B. So for part B, we need to use the conservation of angular momentum. So we will do on the next slide. So we have B part L1 equals to L2, which is I1 omega 1 equals to I2 omega 2. We are given omega 1, which is zero point 0.4 radian per second, and we know the value of the I1, which is 3 in 10 to the minus 3. So we have 3 in 10 to the minus 3, and we will find out I2 and omega 2. We are given that the velocity of this at this point of the bug is equals to 0.16 meter per second. That means the rod has also this same tangential velocity. So v is equals to 0.16 meter per second, and v equals to omega r, which is this formula here. This formula here. So this gives us v equals over L omega. Since the length of this is capital L, the where the bug is sitting, so we have capital L here. 0.16 over capital, which is zero point 0.5, which gives us omega 2. So this gives us 0.32 radian per second. So now we will use this here. So we have V2. Doesn't matter if you put V2 or V here because that's the final velocity. So we have 3 in 10 raised to minus 3 times zero point 0.4 over 0.32, which gives us I2. So we can find out this value, but I2, now the moment of inertia, what is the moment of inertia of the whole system when the bug is at this position? So we have moment of inertia of the whole system after bug reaching there, we have bug plus I rod. I rod we already know, which is 1 over 3 ml square plus ml square, using this formula here. Using this formula here. So we place this quantity here back into the equation using this and put the value of the capital M and capital L. So this gives us 3 in 10 raised to minus 3.4 over 0.32 equals to 1 over 3. Capital M is 0.036 times L, which is zero point 0.5 whole square, plus small m, which we have to find out, times zero point 0.5 whole square. So this gives us m equals to 3 into 10 raised to power minus 3 kg. Let me erase this one so not to confuse it. Yeah. So that's your answer for this question. Thank you for watching the video.